Well, welcome to another RDWorks Learning Lab. Today we're going to do something which I have been planning to do for several, I suppose, couple of 3 months now, but just not got round to it. Now is a convenient point in time to combine 2 or 3 things together. I've got some of my wood that I used to make my pizza oven with. I have fitted a 2-inch lens in here today. I'm normally a 1.5 inch lens man, but today, because most of you guys will have a 2-inch lens, what I'll do, I'll try and make this much more representative of what you might have. And I'm also going to install this double capacity air compressor. So this pump is capable of delivering about 140 litres a minute, which is twice that of the one that's supplied with the machine and probably you had with your machine. But there is no value in putting this pump on unless we take a look at the airways that get down to the nozzle. So we'll take a look at that later, but first of all what I want to do is to set up some standard tests on what was supplied. Now, rather than cut the wood directly onto my steel plate, I'm going to stand it off on 2 of my little magnets, just so we can keep the wood off the deck and get air behind it. Now, because this is a 2-inch lens, the distance will need to be about 19 millimeters between here and here, ideally. But because we're cutting 10 millimeter plywood, I need to be 5 millimeters into the plywood. So that will be the ideal spacing. And all I'm going to do is basically just keep tutting out a 40mm test square. Okay, now I know that I can cut this square out with a 1.5 inch lens at full power, which at the moment is 60 watts here. Although I've got a 70 watt tube, I'm losing 10 watts through the system, but that's something for another day that we're going to have to fix. And I know that I can cut it at just about cut through at 15 millimeters a second. And so what we're trying to do is we're trying to establish the point where it just cuts through, and we'll use that as a reference for our success. So let's just see what happens with a 2-inch lens. Now I've got full air supply on, if you listen. Okay, I've got my full air assist on at the moment, and it's, to be honest, pretty pathetic. But I'll turn some extraction on, because the one thing that happens with wood is lots of smoke, and the fact that the smoke is coming out the top tells me it isn't going through. And we'll reduce the speed right down and find out where it does cut through. Right, so instead of 15, let's go down to 5. Now we know it's cutting because look, the smoke is coming out the back underneath. The smoke's not coming out the top. We've got quite a clean cut on the top there. We're not producing there we go, it's dropped out nicely at 5 millimeters a second. My normal method of assessing whether that's a good cut is to rub it on some paper. And yes, we're getting we're able to, it's not bad, but we're definitely pulling off some charring. So it's not a clean finish. So what we'll do now, we'll wind it up and we'll see if we can do maybe 7 millimeters a second. And it does look as though it's cutting because the smoke is coming out from underneath. Let's have a careful look behind. Well, I think you saw the first time round we had lots of charring here, which means we had lots of excess energy. We've got less charring here, but we've still got lots of excess energy because we're getting reflections off the back. And we're also getting a lot of tarry, sticky debris on the table. So, you know, that's being condensed there, but that would normally float around in the air and finish up in your air extraction system or somewhere. It's got to condense somewhere. It's just that at this moment in time, because I've got this so close to this hard cold surface, it's condensing down on that surface. So that's tar from the wood. I'll just clean that off with some acetone. Now this was our cut at 7 millimeters a second. So we'll just take a look to see how much. Not bad. It's getting better. Right, we're now going to try 10 millimeters a second. Now it didn't drop out cleanly, but my suspicion is that it's maybe caught on the corners. There's a little bit of inconsistency in the cut. Now you can see that we've not burnt the back here now, so we're just on the threshold at 10 millimeters a second of it working. It's just failed to cut there, and it's just failed to cut here, but with a little bit of a push, look. So I think you can see that it's a lovely brown. It's not actually charred at all. And so consequently I suspect that this time when I rub this on here, look at that. It's just the merest hint of something. So for every one of these tests I'm leaving the power at 60 watts. So from full air I'm going to turn that off, and then I'm going to turn it back on, and I'm going to feel it with my finger. And I can just feel now, and I can hear and feel that I've got the merest amount of air coming out of there. Just enough to keep the lens under positive air pressure, but not enough to actually affect the cut that's going on down there. So we'll run the same test again, 10 millimeters a second, and we'll see what effect we have. Now I think immediately you can see that we're probably producing a lot of smoke on top, and it isn't going down through the cut. But let's just see what happens. We have actually cut through, and it is a surprisingly good cut. It's a very nice cut, in fact. So what do we deduce from that? Well, I think what I really deduce from that is that my airflow into the cut is not having any effect. And why is that? There are several things we want to try and establish at the moment. First of all, let me point out to you that the hole in the end of that nozzle there is 4 millimeters diameter. So the nozzle is 4 millimeters diameter on the end. The pipe is 4 millimeter bore, but the elbow inside there is only 2.5 millimeters. Now that causes a big problem. My old pump, which we're currently using, delivers 70 litres per minute, and the new pump delivers 140 litres per minute. The old pump runs at about 4 psi maximum if you stop the flow, and this one runs at 5 psi if you stop the flow, and that's the only way that you'll build up the pressure. When it's leaking away like this, it will never build up to these pressures. So the only thing that we're really interested in is mainly the flow. And here, if we compare 4 millimeters, 12.6 millimeter squared area, 4.9 millimeter squared, that is only 40% of that. So that's a serious problem. We're going to see no benefit at all from putting this 140 litres through this system, because the pressure difference is such that it'll be basically a waste of effort. So the only way that we're going to get any benefit from the flow out of this system is by increasing somehow our bore into here. Now if I drill it out to 4mm diameter from each end, that end seems okay, but it's this end here. Now I don't know whether I'm going to possibly destroy the fitting. If we do, we do. Let's go and give it a try, shall we? And I can see it in that way, so I know that I've got a 4mm passageway through there now as well. So we can immediately dismiss that, because we've now made that 4mm. So the very first thing we must do is go back and check whether or not that's had any significant effect on the airflow that's coming out of here. I mean, it should do. It should double the airflow. Now, as I do say to many people when they comment to me about tutorials, no, these are not tutorials. What you're doing is watching me learning. I've got no idea where this is going. I'm just exploring and observing and responding to what I see. So come along for the ride. Let's see how 12mm a second looks with the increased airflow. Well, there's the answer to the question. 12mm a second. We've just gained 20% by increasing the airflow. And the tissue test? Nothing. 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 And nothing. Now, I don't think we can go much more than that at the moment. That looks to be right on the edge of cutting. Now, the problem as I understand it with cutting wood, and I think that's a pretty good demonstration there, we've just got 20% by increasing the airflow through here, which basically means we've forced more air down the cut itself. The smoke that we produce when we cut wood is very, very absorptive of this laser light. And so consequently you must make sure that you try and keep the cut area as clean as you possibly can. Now, if you can imagine, we've got a nozzle and we've got airflow coming out of here from an inside which is tapered. So it will be coming out of here not in a laminar flow, it'll be coming out here in a turbulent flow like this. Now, when I cut 10mm with my 1.5-inch lens, I'm sitting around about 1mm above the surface. So I am able to force my air directly into the cut. Here we are 15mm away. And look, we're probably losing 80% of the air. There's probably only a small percentage of it that is actually getting down into that cut area itself. And that's the problem. Now, I've just picked up this lens system from the other light blade machine, and it works on a completely different principle, the way that it operates the lenses. In this particular instance, the lens is fitted in the nozzle there, and as you increase the distance, as you increase the focal length, this gap increases, and most of you guys will have a 19mm gap there. Now, with the light blade, they put their lens back further up here so that they keep this distance here constant at around about 4 or 5mm. Now with the light blade, they first of all have got a much smaller nozzle, and so the air is directed out in a much higher pressure and higher flow rate. and that distance to the work remains constant at around about 5 millimeters, regardless of the lens that you put in it. That's a big difference between this machine and the light blade. Now, you may be lucky enough on your machine, because I know that some machines do operate this same system. But down at this cheap end of the range, this is the system that we're stuck with and we have to live with. So what we're really now trying to do is to increase the flow rate out of here so that it can jump across this gap. Now, by increasing the flow rate through here, as we've just done, we've already started to improve the situation, as you've seen. So what I'm now going to do is we're going to have a go at plugging in the other pump. Okay, there's the new pump installed, and it's not a lot noisier than the old pump, a little bit more, but you'll notice that I've got it suspended on a hook. It's suspended in mid-air so that it doesn't transmit its vibrations through to the base, otherwise it would make a lot more noise than that. I have to say, I can already feel it's a lot more air, a lot more efficient. So let's just go over this way. And what we're going to do now, before I even start, I'm going to go and put the speed up to 14 millimeters a second. That's how confident I am that we're going to get some improvement. So if I can now achieve this, it matches what I can do with my 1.5 inch lens. That's now on. Well, that's looking pretty promising, isn't it? Hasn't quite cut the corners, which probably means it's because the beam is dragging just a little bit. But that's 14 millimeters a second, and look. And the quality of that edge, well, let's just do my tissue test. Nothing. 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 Got hardly any marking on the top surface there in terms of residue coming out, and on the underneath it's almost perfect. Should we push it to 15 millimeters a second and just see whether or not we can get a little improvement? This is 15 millimeters a second. Well, we are really on the edge of cutting here now, because I can just see 1 or 2 little wisps around here, but it's still cut, and you would be able to take that out. I mean, that is such a pale brown. There's not a single bit of charring on that at all. That is superb, isn't it? We need to do something else. We need to see if we can find a way of concentrating the air better. And I'm just trying to think how we could do that. My proposal was that there's a problem with the air expanding before it gets to the gap. Well, I've just knocked up a fix to solve that problem. I've put a 3 millimeter hole in the bottom of that extension nozzle. Now, it might look a bit crude, but it will do the job that I want to prove it to do. I made it a snug fit on there, and it finishes up about 5 millimeters above the surface. And now we'll give it a try. Let's see whether we can set fire to the plastic, shall we? Now, question is, has it made any difference to the depth of cut? Well, it may well have done. Let's see whether we can push it another 2 or 3 millimeters, should we? A second. So let's go from 15 now to 17 millimeters a second. Well, that's 17 millimeters a second, and we're just about on the edge of cutting. Again, it's an absolutely superb cut. That is right on the limit. 17 millimeters a second. So all of these results are done with 60 watts. We started off at 10 millimeters a second, which we found was the fastest we could run when we got the maximum airflow from the 70 litre pump. Surprisingly enough, it didn't seem to make a lot of difference when we turned the air off. But as we find out later on, there's a good logical reason for that. Then we moved to a higher flow rate by increasing the bore through the elbow. We virtually doubled the flow rate. And what we found was we could easily match 10 millimeters a second, and we were then able to go up to 12 millimeters a second. We then changed the pump to 140 litres, and with no other changes we went from 12 to 14 millimeters a second. In fact, we found that we could just about make 15 millimeters a second. And then I made the extension nozzle, and what that did, that changed the flow easily from 15 millimeters a second to 17 millimeters a second. I was able to get from 10 millimeters a second to 12 millimeters a second with the original 70 litre pump. The question we haven't asked yet is, where could I have pushed that 12 millimeters if I had that extension nozzle on? Let's see if we can answer that question now, shall we? Okay, let's see how we get on. Well, I don't like to say this, but there's smoke coming out underneath, and smoke coming out underneath is a very good sign. Okay, I would say that again we're right on the limit here, because looking at the way that there are shreds left around here, it hasn't quite cut through cleanly, but it's cut through enough that it wouldn't take much, look, to press that out. And look at that, that is a superb cut that's got no charring on it at all. With the 2-inch nozzle we started off at 10 millimeters a second. With the shroud on, 70 litres, we were able to get up to 15 millimeters a second, so that's a 50% increase. If we want to spend the money on a double capacity pump and put the shroud on, we can get another 2 millimeters a second. The question is it worth the extra money to buy the bigger pump? I've got mine as a spare. I purposely bought a spare, but when I bought the spare I bought the bigger pump. Looks as though it doesn't really need it, but it's an interesting point. In fact, I'm half suspecting if I put my 1.5 inch lens in, I'll be able to probably get that up to about 100 millimeters a second. Well, just as a footnote, this is my 1.5 inch lens, 17 millimeters a second. Doesn't really want to know. It just about goes through, but I can't push the parts out. So this is the 140 litre compressor with the gap as small as possible, a 1.5 inch lens, and I'm stuck at 15 millimeters a second. So I can actually go and do a better job with a 2-inch lens, which is rather surprising. Anyway, thanks for watching. I hope you've learnt as much as I've learnt.